Okay, for the general power rule, it's going to be the derivative of any number to n equals nx to the n minus 1. So just going down to the example so that you can see it easier, find the derivative of y is equal to x cubed. So you're going to multiply 3 down, your exponent, keeping x there, and subtracting 1 from 3 is 2. So the derivative is 3x squared, which, going back to your general power rule, you're just multiplying your exponent down and subtracting your exponent by 1 to get your derivative. Here's a second example. 5x to the 4th power. To find the derivative, you multiply by 4 times 5x. Subtract 1 from 4 is 3. You can simplify that to 20x cubed. For something like this, find the derivative of 2x plus 1 to the 1/2 power. You multiply 1/2 down, because that's your exponent. Multiply by 2x plus 1 time to the power of negative 1/2, because you're subtracting 1 from 1/2. And then you also have to multiply by 2, because it's the derivative of 2x plus 1, which is chain rule. So simplify that. The 1/2 and the 2 cancel out, so you're left with 1 over 2x plus 1 root. Okay, so there are 2 basic properties to natural exponents. I'm going to write the first one now. When you're taking the derivative of e, it just remains the same thing. So ex is still ex. Here's the second one. So any number, a represents a constant to the power of x, becomes the same thing times natural log of a. So now we're going to go to an example. Find the first derivative of 3e to the 5x squared. So you'd have to take the derivative of your exponent, 5x squared, which is 10x, and then your 3e to the 5x stays the same because of your first property. So you'll get 3e to the 5x squared times 10x. So 5x squared becomes 10x. You can simplify this into 30x e to the 5x squared.
So we're going to find the first derivative of the problem. Well, as you saw in the properties that we just gave you, the e to the 2x minus 1 just drops down. However, the derivative of this exponent right here is 2, so you multiply the whole thing by 2. And the answer would be 2e to the 2x minus 1. Okay, here's another example. What you would do here is you would take the original problem, what it came from, and then you would multiply it by ln of 10, like shown in the example, shown in the properties, and then you would take the chain rule of the exponent, which is 5, and that's the answer.
So just as there are 2 basic properties for the derivatives of natural exponents, there are also 2 properties for the derivative of logarithms, and I'm going to write them now. So that's your first one. When you're taking the derivative of a log, your base becomes ln of that, and x goes in front, all under 1. Now here's your second one. So the derivative of natural log of x is going to be 1 over x. So whatever x is, that's what it will be. Now moving on to our first example, find derivative of ln 2x. So it's going to be 1 over 2x. But you have to do chain rule as well, so you're going to multiply by 2. So you'll get 1 over 2x times 2. Again, the 2 comes from chain rule. And you can simplify that to just 1 over x. Alright, so for our other example, finding the derivative of this equation, what you can do first off is rewrite the equation. You're going to have to know your log properties to be able to do this. So you could rewrite it as y equals sine of x times log base a times a. And coming from your log properties, you know that this would be equivalent to number 1. So then what you're really left with is y is equal to sine x. And take the derivative, knowing your trig functions would become cosine of x. And remember that this y prime is the same thing as dy over dx, so it means the same thing. Now moving on to our second example, find dy of dx of this equation. You can rewrite this to become ln of 5x to the 1/5 power. And to take the derivative of this, you have to use chain rule. So 1/5 times ln 5x to the negative 4/5 power times 1 over 5x times 5. And you can simplify that to 1 over 5x 5 root ln of 5x to the 4th power. Just going to extend that line. So just going through and explaining where these numbers are coming from. With chain rule, you're going to take your exponent, multiply it down, and because this is 1/5, you're going to subtract 1 from 1/5, so you get negative 4/5 multiplied by 1 over 5x, which is your derivative of the ln 5x, times 5. And then just simplify. Well, they want you to find the derivative of x times ln of x, which is product rule. So for product rule, it would be f of x times g of x. And this is the generic version. To find product rule, you do f prime of x times g of x plus f of x times g prime of x, which in terms of this problem, x times ln of x, you would get 1 times ln of x plus x times 1 over x. Simplified to 1 plus ln x. 1 comes from the derivative of x, and ln of x stays the same because it's g of x. The second problem, f of x stays the same, and g prime of x. So derivative of ln x is 1 over x. The second example, find derivative of ln x cubed. You have to use chain rule. So you're going to multiply your exponent down. So 3 times what's still inside, ln x squared, because it's 3 minus 1, times 1 over x, which is the derivative of ln x. And you can simplify that down to 3 ln x squared all over x. Okay, so for a problem like this, you want to read it slowly, make sure you know what it's asking for. A line with slope m passes through the origin and is tangent to y equals ln x. What is m? So m is slope. So first thing you're going to have to do is find the derivative of y is equal to ln x, which from your properties you should know is 1 over x. So dy over dx is equal to 1 over x. Now, the next step, you know that you're looking for some point that it's tangent at. You don't know what point, but you can say that some point could be a ln of a. And the reason why I'm saying a is it could represent any number. So if you put in 30, so it would be 30 would be your x value, and your y value would be ln of 30. You just haven't solved it out because you don't know what a is. And now to find the slope, you just use your simple slope formula. M is equal to ln a minus 0 over a minus 0. So remember, your point is a ln a, and your second point is 0, 0, which they tell you in the problem that it passes through the origin, which is the point 0, 0. Now you can simplify this slope to become ln a over a, which is the same thing as 1 over a times ln of a. And you simplify this further to become just 1. And since it equals 1, you can say that a is equal to e. And when you take log base e of e, it's going to be equal to 1. So 1 over a is equal to 1 over e. Okay, so your next problem. At what point on the graph of y is equal to 2 to the t power minus 3 does the tangent line have slope 21? Sorry about the little scribble. Okay, so first thing, you're going to take the derivative of this equation, 2 to the t power minus 3. So y prime is equal to 2t times ln of 2. And then they also tell you that the slope is at 21. So to find a slope value, you'd have to plug in 0 into the derivative to get that. So you know that y prime is equal to 21. So you can set these two equal to each other. 2t times ln of 2 is equal to 21. Next, you can divide out the ln 2 to the other side. So you have 2t is equal to 21 over ln 2. And then you can take the ln of both sides, which is one of your properties. You should know this. And just move it up. You'll get ln 2t is equal to ln of 21 over ln 2. And just to simplify further, you can move your t to the front. It's one of your properties again, your exponent. So it becomes t times ln 2 is equal to ln 21 over ln 2. So the right side stays the same, and once again we just moved our exponent down to the front, which is one of your properties. You divide the ln 2 out, and you'll get t is equal to ln of 21 over ln 2 divided by ln 2. You'll want to take your calculator, plug this all in, make sure you use your parentheses correctly, and you should get the value of t, so approximately 4.921. So that's the point on the graph where the tangent line has slope 21.